Welcome to the tutorial for the NPTEL course Programming Data Structures and Algorithms in Python. Uh, so today, uh, as we do usually, we choose a few problems and then we try to solve those problems with the help of concepts that we have learned in the class. Uh, so today first problem is binary representation of two numbers, and we'll check whether they are anagram or not. So anagram is basically a number. Anagram basically it is defined as a word or phrase. It is made by transposing the letters of another word or phrase. So for example, let us say we have a word uh, as it is given here. We have word cat, so we have one C and one A and one T. So we can uh, we can rearrange these letters to get a word like tack or maybe act. So with the help of the letters available in the word, we'll try to create other words. So all those words will be called anagram. So like here we can see rescue. So secure is a anagram for the word rescue. So what do I mean here, that the whether I want to check the binary representation of number, whether it's anagram or not. So basically, for example, if we see here, the binary representation of 8 is 1000. So basically we have three zeros and one ones. And another number we have here is 4, and a binary representation of 4 is basically here, as we can see, is 0100. So basically here also we have three zeros and one ones. So as we know that the binary numbers are represented by the combination of zeros and ones. So if the length of the number is same for the for I mean for the two numbers, so in case let us say uh, the binary for decimal 8 and the binary for decimal 4, so we can see that the length is same, length for both of them. The number of digits are 4 in both of them, and if the number of zeros and number of ones are same, then we can call them anagram. So if we see that 100 and its anagram could be 0100, or it could be 10 uh, sorry, or it could be 0010 or 0001. So all of them would be called the binary anagram for this particular number. So now how are we going to approach this problem? So first of all, as we can see, first we require to convert this decimal number to a binary number. Then only we can talk about whether this particular number is an anagram to other number or not. So then we will look for I mean I mean here in this particular line, I have discussed the definition that we are going to use. So basically, the remainders of recursive division of decimal number 2. I mean of the decimal number by 2 and arrange from last to first. So let us say we have number 5. So we'll divide 5 and the remainder will be 1. And then if we then and the integer output would be 2. Then if we divide it by 2, then our uh, you know remainder would be 0, and then we'll be left with 1. And if we divide it by 2, we will have 1, and our output would be 0 in that case. So basically we will rearrange this from last to first, and in this case last to first or first to last is same. So basically it would come out to something like 0 0 0 1 0 101. So basically that is the definition. For this definition, you these two stars, basically here I have fixed a link, so you can follow this link to look for the definition and learn more about this if you are not very much aware. Then, as you know, as we have already discussed, binary numbers, these are made up of 0 and 1. So uh, we have already talked about it, that if the number of zeros and number of ones are same in that particular number, then we can call them to be an anagram. The one thing we need to be careful about, if we try to convert the binary representation of 4, so it would come out to be 100. But no matter how many zeros we add before it to the left, the value of binary representation, the decimal representation of this binary number will remain 4, so it will not change. So we can add any number of zeros before to the left of the given number. So in this particular case, if we compare it with 8, so 8 has 4 digits in the number. So but 4 has only 3 digits, so we can simply add a 0 here, and then we can compare both of them whether they are anagram or not. So uh, yeah, so we will look for the program, and then how can we uh, check whether the numbers are anagram or not. So for that, uh, we shall go to our notebook. I am restarting it now so that any output that is stored is gone. So now, as we have discussed, first of all we'll try to convert our given decimal number to a binary number. As we have discussed, we are going to follow the same definition. So for that, what I'm going to do, so this function basically will take one argument that will be a number, and it should be an integer. So we have already discussed how we can restrict our program to accept only integer values. So you guys can do it on your own. Then we are going to initialize a dictionary, initialize a list, and then we will say that, okay, we'll start with a while loop, and we'll say, okay, as we have discussed that uh, at the end, when we keep dividing it by 2, at the end we get result 0. So we say, when it goes to 0, then there is no point for the dividing. So we say, okay, while num is greater than 0, then we will simply append our this list by uh, you know uh, we'll append this list by the remainder of num divided by 2, and then we will update this number by floor division of 2, and then we keep on doing it until we get this num greater than 0. So in this particular case, we don't know that how many times this division can occur. So because it depends upon user how large number he provides and those things. So we are iterating with a while, or we could have iterated with a for as well. So then after, as we have seen in the definition, we have appended these values, like we did our first division and got the remainder, and we have appended them in that sequence. So now we need to reverse it, and we have already seen that how we in last I mean in one of the last tutorials we have seen how can we reverse the list. So basically this is the expression for reversing the list, and then we are going to join the list, and there should be no space in between, so no space or anything else in between. So then we are going to join all the elements in the list. So that's how we are going to get our output. But for this we have written a function, but it's not necessary because there is already a built-in function in Python that does convert the decimal number to the binary. So basically this function is called bin. So basically bin takes one argument. So if we give an integer value in place of none, so bin calculates the bin calculates the binary representation of that particular decimal number. But the output of this bin num, basically it it has zero b at the start, so we need to be careful while taking the output from this function. We need to remove the first two letters when we are when we are using this inbuilt function bin in this particular case. So basically this simply represents that okay, the number after this is a binary number. So, and I have given, just for you to go through in that, star, I have given this this link, so you can follow this link and learn about that. And the same link is given in the in the presentation. So, with the help of that, also you can reach here and learn about if you wish to. So now we will run this function. Yeah, so notebook is ready now. So we will see that for a number 717, we will try to calculate the binary representation of the number decimal number 7 by 7, 717, and the same binary representation we will also try to check with the built-in function bin. So yeah. So when we run this, as we have discussed, this zero becomes, uh, you know, uh, uh, just to the left of the output of this decimal to binary conversion from the built-in function bin. So what we can do here is we can simply omit the first two digits, that first two places, that is 0 and 1, and then we can start with 2 till end. So we are going to get the same number in both the cases. So this is how you can use the bin function if you wish to use the inbuilt one. So just just for the sake of completion, I have also added how you can convert from binary to decimal. So basically if we try to follow the definition of binary to decimal, then basically what the definition requires is yeah. So basically, that definition requires is that we can we can first take the this is power, this is a power, this is a function to calculate the exponent. So I represents the position of the of the of a of the digit in the number. So let us say we have number 735. So this is the zero. I mean, so in this function, so this I starts with 0. So when we are going to calculate the uh, you know okay, so first of all, sorry. So we'll start with first we'll calculate the first we'll start with saying that okay, the binary it should not reach to 0. So when it is greater than 0, or when it is not equal to 0, then we will calculate the modulus of this particular number binary, which is the input to our function, which is input to our function bin to decimal. Then we will uh, we will calculate the remainder after division by 10, and then we will multiply this remainder uh, by the power of uh, by the power by the 2 raised to the 2 raised to the power, the first division, second division, third division, and so on. So basically we have initialized our I with 0. So in first case we are going to get, let us say our binary number is 0 1 1 1 0 1. So if we divide it by 10, so yeah, just I'll put it here. So if we divide this by 10, so remainder will be 1. So we'll multiply 1 with this, and then we will do the addition. Then we will further divide, uh, and then we will update the number by floor division by 10. And then in next iteration, the second remainder is going to be 0, because uh, after first floor division will be remained with this number, so remainder will be 0. So we'll multiply it with 2 raised to the power 1, and we'll proceed, we'll process this until our binary becomes 0, so or the floor division of binary becomes 0. So you know so this is how we are going to convert our binary to decimal number. So as we have already calculated decimal to binary, so we converted our 717 from decimal base, 10 base to 2 base, so we got this value. So we are just going to take this value. Actually, I think the same value is already here, but just for the sake of completion, I'll just uh, okay. So yeah, first we need to run this. Yeah, now if we try to calculate it, then we can calculate, or we can calculate the similar thing by using another inbuilt function. As we know, it's integer, and then we will give our binary number, comma, the base of this number. So base of this particular number, if this is a binary number, this number is a binary number, so base of this number is 2. So for we will try to convert it to int, a number with a base 2. So we'll see what output we can get here. Okay, sorry, so it should be a string based. So yeah, so we can get 7 by 717 or 717 in both the cases, because so this is an inbuilt function, but this requires a string input here, and then we require, because if we simply give this number, so it does not know whether it is a decimal number or binary number or what. So it I mean, as per the syntax, it requires you to convert it to a string, and then you just give the base of the number, and then you convert it to an integer. So now, as after the conversion from decimal to binary, so now we have access to the number of zeros and ones in the converted binary number. So for that, we have written one more function here. So what we are going to do is, let's, because bin is already an inbuilt function, so let's not use bin here. We will use binary, could be better, because bin is already an inbuilt function, so that is why it was showing in blue color. So, and we should not use variable names uh, with the name of inbuilt function, so that's not a good practice actually. So now we are going to define a function. It is going to create a dictionary which will have keys as 0 or 1, which are the digits in basically binary system. So, and we will update the values corresponding to the dictionary 0 or dictionary 1 with the number of times they occur in that particular number. So basically, so here what we are doing, we are initializing our dictionary, that is dic bin, with key 0, and we are initializing with key 1. Then we are calling that, okay, for I in list bin. So for all the i's in this particular list, so which list which we had created here. So this list is nothing but it basically gives us it gives us all the digits of the binary number in a list format. So if you wish, you can, simply check it. It does only that. So as it is in a list format, we can call all the elements of the list in this for loop. So for I in a list bin, we apply a condition if I is equal to zero. If I equal to, so it's a conditional equal. So when I equal to, this is a string zero. So we need to be very careful with that. So we will keep on updating every time when I turns out to be zero, we'll update our dict bin with +1. Or else, if it is other than zero, then it has to be one, and we will update the key associate, the dictionary with the key one. So if we run this function, yeah. So this function is run. So now this basically is a counter here. So we have written two functions. First converts decimal to binary, and then after converting to binary, it gives us the number of zeros and ones in that particular binary number. So, but as we have already discussed, one more important point, that there could be a possibility that the length of the numbers that we are comparing may not be equal. So, we should also be careful that the length of those numbers should be equal. And so, for that, for the smaller number, we will keep on adding zeros to the left till both the numbers become, equal. So for that, we have come to our final function. So what this function does is it basically checks whether binary numbers are anagram or not. So basically, it's going to take two inputs, number one and number two. So these are going to be a decimal number. So first, we will convert them to binary number by using the function we have defined. So if you want to define convert it with the already inbuilt function, then for that you need to do is bin num1, and then as we have already seen, it must start with with the place 2, because place 0 and place 1 is taken by 0b, which is not the part of the binary conversion of a decimal number. So if you want to do that, we'll have to process it like this. But anyways, we have already written a function, so we need not to bother about that. But in case if you are willing to use the inbuilt function, you can do that. Then we are going to check whether the length of the binary function, the binary one, is same as the length of binary two. So if the length of binary one is more than binary two, then we will simply calculate the difference, and we'll multiply it with a string zero. So uh, when we are multiplying, let us say 3 with another string, maybe s, so it will be nothing but it will be um, s. So it will be 3 times s. So basically what we are doing here is we are adding zeros to the left of our number. So basically, as you have followed this binary number that has been calculated using this function, it is in a string format. So if you see here, we in our conversion we had appended it with a string. Okay, and then we simply had joined all those elements with nothing in between. So basically the output is a string output. So what we are doing here is we are adding the string of zeros to the left of the string of the binary number. So this is how we are going to get, so basically we are going to get some zeros and the binary number. And if otherwise, if the length of binary number 2 is greater than binary number 1, then we will update we will update the number with the lesser length, the similar way. So now we are going to count the we are going to count the number of zeros and ones in in our binary number after updating them for their length. So if their length is not equal, we are going to add zeros, to the left of the number which has a lower length. So now, as they both have the same length or the same number of digits, what we are going to do, we are going to check whether they have equal number of zeros and equal number of ones in the counter or not. So when we are going to count, so what counter does is it just returns you a dictionary with keys 0 and 1, and corresponding to key 0, the value is how many times the 0 has occurred in the decimal number, and corresponding to 1, how many times the 1 has occurred in the decimal number, sorry, binary number. So basically, we are going to check whether these two dictionaries are equal. If they are, it is going to return us true. If not, it is going to return us false. So what we are going to do is we are going to check, we are going to supply some numbers. So as we have already seen, 4 and 8, they are anagrams. So we'll give 4 and 8, and the output comes out to be true. So now you can check other numbers, maybe 16 and 32. So I'm choosing numbers in 2 raised to the power something, you can see. But if I choose number like 5 and 10, so 5 multiplied by 2, so uh, and then we are going to I think there is some issue. uh, okay, just wait for a while. Okay, so it's 101 as we had already seen. uh, okay, so 1010. Okay, so yeah, so as the length of this 10 is going to be 4, the length of 5 is lesser, so we will update the output of 5 with a 0 added, and then we can so let's choose some other numbers, maybe. Okay, control enter. I don't know why it's not responding right now. uh, yeah, now it's up. Okay, so let's say I'll choose a number 3 and maybe 7. It is going to give us false because if we check the conversion, it may not possibly have the same number of digits. So yeah, so even if the length of this is 2, the length of this is 3, so even if you convert the length, I mean you process the lengths to be equal, so for that you will add 0 to the left of this particular output, then it will be 011, which will no way is going to be anagram of 111. So yeah, so but earlier I had told you that you can add any number of zeros just to left of the binary number, and the same is the case even for the decimal numbers. The value is not going to change. So basically, the decimal equivalent is not going to change. So if we try that, so we can see that bin of okay, bin of 8 is basically 1000 we are getting here, and we have added 100 of zeros before that, and we uh, try to calculate the integer value which is equivalent to 8, and we have already seen, we have calculated the integer value for this particular binary number. So that comes out to be 8, which is same as the decimal conversion of the binary 1000. So next problem that we are going to choose today is, yeah. So basically, we are going to read the data from a file, and then we will try to append the file or write a new file after doing some, mathematical operations, or maybe some other operations if we wish to. After that, whatever output we are going to get, that output will try to write in the same in the new file, or will try to append a already existing file. So it could, it could be really useful in many applications. I mean, if in data science, in many areas, what happens is, uh, there are companies which keep on collecting data from many sources. So like you go to some place, they will ask you to update a they'll ask you to fill a form, and then in that form they'll extract, they'll get data from you, and then they will update that data in a dynamical in your dynamically shared file. So basically that file will keep on updating, and then those updates will be shared with the people that are interested in those details, or the stakeholders for that particular industry. So then people require to process that data and gather the information that they need. So basically, what we are the approach we are going to use is, we'll try to open the file that is existing in our in our hard drives, or maybe available online. So we'll try to open the file, and then we will basically use the read command to store the data in a particular variable, so that we can process our data further uh, by manipulating that particular variable, or something like that. So now, if the data is written in various lines, so like first line, and then in second line, third line, fourth line. So if that is how data is stacked, then we will use a built-in function split line, so that we get the data, and not an unnecessary string that is slash n. And then we'll process the data as we wish, and then we will append it to the existing file, or we will write to a file that we wish. So uh, so yeah. Yeah, so basically for our problem 2, uh, you can see that in the online cloud, I have one input. This is a text file, so I have some input data in this file. So that data basically looks like this. It First line, it says decimal, and then in second, third, fourth, fifth line, it has a data which tells that, okay, we have a decimal number 1240, decimal number 1315, decimal number 25, decimal number 100, and they are separated by this tilde notation. Then we have on in sixth line, we say, okay, now it is the turn for binary numbers, and 100 is a decimal number, and 100 is also a binary number. So basically it tells us, okay, in this particular file, it differentiates, okay, this particular data is a binary 100, and others are also binary data. So basically the first part of this particular string tells us that whether this is a decimal number or a binary number. Then there is a separator, that is tilde, and then after that we get the value associated to that number. So we are going to play with this particular file, and then we will try to produce the output and write those files, and append those files to uh, our just for our understanding. So basically what we are going to do is we are going to use a handle that says, okay, with open, this is a file name, and this basically tells us that we want to read this file. Okay, so we need to be very careful. If we by mistake do something like we just say write, then the existing file will be updated and all the data in the file will be wiped out. So we need to be very careful about that. Then we are opening this as f. Okay, so basically this data is being read into our buffer memory as f, and then we are going to uh, store this data into a list. So we are going to read this data, and then we are going to read this data by splitting all the lines. So if we do not do this, the list will have element. So let us say the list would look something like this. So ELE1, and then it would look something like this. ELE2 slash n, and so on. So this particular slash n is basically redundant for us, and we do not want this to available in our list variable. So for that we are going to do the split lines, so our data does not have that redundant slash n. So now as we have seen that our data is divided into two parts. One is the decimal numbers, and one other is a binary number. So we are going to create a dictionary. In this dictionary, we are going to initialize a key that represents the decimal number, and another key that represents the uh, binary number, and the values will be stored in a uh, values are going to be stored in a list. So now we say if I if I is decimal or I is binary, because we do not want them to be part of our uh, dictionary. So what we simply are going to do is we are going to, if I is either decimal or binary, we are going to pass. We are not going to do any operations in that particular case. But yes, if it's anything other than binary or decimal, then we are going to split it with tilde. So we have already seen this split function. If you remember, then what we used to do is we used to say, okay, list dot uh, the sorry, we used to say element dot split, and then we used to uh, split it either with uh, comma or comma separator or with a space separator. So you can like in this particular case, our data is with tilde separator, so we are going to split our data with this tilde. So and then we are going to say if first part of the splitted data, if it is dec, which represents the decimal number, then we are going to update our dictionary with the key dec that represents the decimal number, and we are going to update the so basically after the split you will be having your number in two parts. So one will be dec and another will be like maybe 1275. So depending upon whatever are the values stored in your data. So this basically represents the zeroth this basically represents the zeroth element, uh, and this will represent the first element. So we will check with the zeroth element whether it's a decimal number or a binary number, and then we will update our dictionary with the value corresponding to that number. So, and then if if the other case is if our data is if our data says that the number associated is binary, then we will update the key in our dictionary, the value corresponding to the key bind in our new dictionary. So the which basically represents the binary numbers. So now we will try to do another operation. We will say, okay, whatever data we are given with, so if we are given with a decimal data, we will convert it to binary, and if we are given with a binary data, we'll convert it to decimal. So for that, we will for this interconversion, we will create another dictionary that we'll call interdict. Okay, so okay, so uh, yeah. So then we are going to initialize with a key that is B to D. So basically this will say that, okay, binary to decimal conversion. So if our number is binary, if our list is or if our list contains the binary numbers, we'll convert them to decimal. And D to B, if our list contains decimal numbers, we'll convert them to binary. So now for that, what we are going to do is we are going to iterate over the items in the dictionary. So items in the dictionary are going to be key and values. So as you all are aware that the structure of a dictionary looks something like this. So there will be a key and there will be a corresponding value. Okay. So and there can be further nested dictionaries. So for that it would look, so we have seen nested dictionary in our last tutorial, if you guys remember. So then it would have further some key and some associated value, or maybe it's just have another key associated, and then you are going to uh, have this value, let us say maybe inside or something like that. So this is how you are going to have so basically for this type of nested dictionary, this is a key, and this another dictionary inside it represents the value corresponding to that particular key. So basically the dictionary contains a key and a value. Those are mappable in Python. So now we are so for I comma j in new dict, so new dictionary is this one. So where we had stored the data from the input file. So we had we had classified the data based upon the dictionary value, so sorry, dictionary key. So if dictionary is dec, it's a decimal number, is if dictionary is bin, it's a binary number. So now we are going to iterate over I and j in the new dict item. So basically the I represents key and j represents value. So if I is bin, then we are going to iterate over the elements in j. So if you remember our corresponding to the key, deck or bin, we had our values as a dictionary. So what we are going to do is we are going to iterate over that dictionary, and then for every element we are going to we are going to convert them to a decimal number. So basically if they are binary, we are going to convert them to a decimal, and we are going to store them in the list that is corresponding to the key B to D in interdict dictionary. And then if the I is not bin and is deck, then we will convert we will convert them uh, to a binary number. So I mean, these are the inbuilt function I have used here. You can also use the function that we have written. So but yeah, it's just for our understanding. So I have used either of those functions, so we need not to worry. We can use any of those functions, but we need to be careful when we are using inbuilt bin. We need to let go first two elements in that particular string. Okay. Now we are going to write our output of this particular, I mean, the output of this particular conversion. So what we are going to do is we are going to, as we have discussed with open, then we are going to say file name, and then we are going to say, okay, this is a keyword for write. So we are going to say, okay, please write this particular file that we are mentioning. So this file is different than the existing file, that we need to be careful. If it if we are not careful enough and we update the existing file by write command, all the data will be wiped. Then we are simply going to say okay, we are going to say write binary. So in first line we are going to say write binary. In second line we are going to say, okay, please, sorry, after binary we are going to say please change the line. And then we are going to I mean, as we are going to represent all the binary numbers below it. So if you remember, in our input file, below decimal numbers we define all the decimal numbers, and then below binary numbers we'll define all the binary numbers. So on the similar note, what we are going to do is we are going to write under the binary, we are going to write all the converted binary numbers that we had converted from the input decimal numbers. So then we are going to, as you know, the data can be written only in a string form using this writing syntax. We can only use the uh, you know string data. So that is why I have converted this I, which actually is an integer form, to a string form. Yeah, but there are ways to write the numeric data as well, but for now we are not going into all those things. So what we are going to simply write our data, and we know if we want to read that data, if it is in, even if it is in a string form, we know how to process that. And because we have already done that in the last part. So we are going to write this write all the i's here, so which represents the binary data under this header binary. And then we are going to change line, and then we will write decimal. So after binary, just below that we will write decimal, and then we will input all the decimal values in the uh, in the particular, we'll dump all the decimal values in the particular file, updating new line at every iteration. So we will have our decimal numbers one by one in consecutive lines. So now if we run this, so what we are going to get is, we have written our file output underscore test dot text. So okay, right now its file is already here, so we will just delete it so that we are sure we are doing the okay. So output test dot text, there is no such file, so we are going to run it, and we'll see that this file is produced, and we'll check the content of this particular file. So as you remember, what it did is, first we converted uh, all the uh, uh, all the available uh, decimal numbers to binary, and then we have written those binary numbers here. So under binary we have written the this is a binary for, we can check in our input text. So this is a binary for 1240, next is a binary for 1315, next is a binary for 25, and in a fifth line it's a binary for 100. So we go to output for text. So if yeah, so if we check our decimals, so you remember, so first one is decimal for 100. So for 100, our decimal was 4. If you remember, for 1000, our decimal was 8. So these two are already, it's kind of remember to us. We can check the other values as well. So corresponding to that, we got 42 and 29. But other than that, what we could have done, we could have, corresponding to as in our input test file, we could have just next to this decimal, we could have given the binary values, and next to this binary, we could have given the converted decimal values for this particular these particular numbers. So for that, we what we are going to do is we are going to okay, so yeah, so we will make a duplicate. Okay, so this is the output dot output test. So this was our output underscore test dot txt. So we will update this file. Okay, so we'll update this file, and we'll see how we can update and what output we are going to get after that. So remember, we are going to update this particular file, output test 3. So here it's output test 2. So we are going to say output test 3. So as you know, we have seen that how to read the file, how to write the file, but here we do not want to read or write, because if we write this particular file, all the data will be wiped out. So we are going to append the values. So we are going to basically change this file by keeping all the existing values and updating the further values as we require. So all the iterations and everything remains same. What I am going to do is I am just going to take the I'm going to write all those the values in this particular dictionary. I'm going to append those to this particular file. Everything else remains same, so we need not to worry. We'll simply run this, and we'll see what happens to our file. So you can see that the same thing has been repeated. So because we had appended with the same values, so same values has been repeated. So our new file has been created. We have, sorry, our same existing file has been appended through, through this append privilege in our Python. Then if then what we want, as we have discussed, what we want is we want to you know side by side, we want to say, okay, if corresponding to this decimal, we want our value in binary, corresponding to this decimal, we want our value in binary, so side by side, so it will be easier for us to um, uh, to know. So it will be a kind of dictionary that will tell us, okay, this is, if this is the decimal, if this is a value in decimal number or base 10, so this will be value in base 2, this is the value in base 2, this will be value in base 10. So it will, that kind of dictionary we can create. So now we are going to write a new file, which is output. So this already is here, so what I'm going to do is I'm going to delete this file. Yeah, so uh, yeah, here, so I have, I have tried to write a new file, which is output test underscore one text. So as I have given the keyword as write, so a new file will be created, and if the file is existing, all the existing data will be wiped out. So, or in other words, you can say your existing file be replaced by a new file with the same name. Okay. Now we are going to, for a header, we are going to write it like decimal, and then corresponding to, after some tabs, we are going to write binary. And then for, we have used this zip command. So using this zip command, what we are going to do is, uh, yeah, what we are going to do is, first we are going to iterate over the interconversion dictionary and the existing dictionary from the existing input file. So existing dictionary, if it has a decimal values, then it will be side by side. It will be updated with the with another dictionary that has values after conversion in binary form. So, after processing all this in a same manner, but just only difference is we are now updating both the dictionaries, and in between we are giving some tabs so that they are not they don't come so close that we are not able to differentiate between them. So you can try after removing those tabs and all, you will see that it will be difficult to differentiate. So it's handy if you use these tabs for our convenience. So and then the same thing will be repeated for binary numbers and the corresponding converted decimal numbers. So if we run this, our output test underscore one file is being created, and then we can check the output of this file. So you can see that corresponding to the decimal values we have the binary values, and corresponding to the binary values we have the converted decimal values. Okay. So this is how we are going to handle the given data as a input, and then we are going to process it. Or if for if we want to use this data for long, for many purposes, so or any application, then it would be handy to store the output of your calculations in a file. So this is a handy way to do that, although there are even better methods or ways or libraries to do those things, but it's a good for the starting. Then next problem we are going to choose is okay, yeah. So next problem we are going to choose is like we want to remove the associated keys and values if we want to I mean after checking a particular substring value. So let's say, I mean, you are a data company, and some data are either fake data or overlap data. Then you want them you want to remove that data with respect to a given keyword. So basically in this particular case, we are given with a dictionary which has numeric values like 1 2 3 4, and the numeric keys, and the values are given in a string form. So for those values, we want to see if there is I mean, if in this particular data, if the substrings like sunny or school, if they appear, we want to remove that data. So by saying if we want to remove that data, I simply mean that the key and values both should be removed. So we can see that. So it's basically I mean, it's a problem of finding. So we want to find this sunny keyword or this school keyword. So like in this particular value, you can see there is a school keyword. So this has to be removed here. If this sunny is with small s and this sunny is with capital S, so we don't want this to be removed. Maybe this is a problem of overlap. So we want to keep only sunny with small s or capital S or whatever. So like here you can see that this sunny is with a small s. So for that, as we are going to do operations on a dictionary in a iterative manner, so we need to define a new dictionary first, and then we will check whether this particular element is available in this element of the dictionary, or this element of the dictionary, or this element, or this element. So in whichever elements we find it to be there, we are not going to update those in this dictionary. So we are going to update only, like if we choose this particular keyword Sunny, we'll update this in new dictionary, we'll update this in new dictionary, and we'll update this in new dictionary. We are going to omit this one. Or if we see school, then we are going to update this. We are not going to update this. We are going to omit this, and we are going to update this one. So that's the whole idea. Yeah. So as we have already discussed, so this was the dictionary we were going to use. Uh, it is visible to us all. I'll just do some editing. Okay. Yeah. So now dictionary is visible to you. You have four keys, one, two, three, four, and corresponding to that we have some strings. Now we we are going to define some substrings, maybe sunny or school, or you can also use this substring, that is was or the or open or whatever, or maybe this question mark. Maybe you do not want any questions in your data, so if you can also omit the data that is either with question marks, or the sentences that are going to start with question words like what or when or how or something like that. So now, as we have already discussed, here we require to initialize a new dictionary, because in the iteration we will be updating the dictionary, and if you update the same dictionary in the iteration, it is going to give an error. Okay, so that's why we have initialized a new dictionary. So right now it does not have any key or any value, so it's an empty dictionary. Now uh, we are going to iterate over the items in this particular dictionary. So basically, when I say a key comma val in test in this dictionary dot items, so the first element will represent key, second element will represent values. Now we are going to use and it's a very useful key type of function in this in the Python. So basically we are going to use or the keywords, maybe we can say, if not any. So as we have discussed, if we do not have either this or this, if we do not have them, then we are going to update our dictionary. Okay, so this simply means that. So now we are saying, if I in val, so I in val means, so when we say that test dot dict dot items, so when we iterate over val, it means we have one value this, another this, another this, and another this. So these are the strings. So we already know that strings are also the sequence. So we are now iterating over those strings. So in a particular val, so let us say why we are iterating here now. So corresponding to I in here, so we have it will start with T, go to O, D, A, Y, and so on. Space will also be considered as a string, and as a string literal. So it will iterate over that and check that if not any I in that val, for I in sublist. So we have this sublist, so we should not have let us say the sunny or school, any part of this sublist in this particular string. So if we do not have this, it will be appended to our new dictionary. If it is there, it will not be appended. So if we talk about this, like su double and y is not present here, because here the su double and y has capital S, but this is a small s, and these are case sensitive, so it will consider it like it's not present here. So sunny is not present here because in our substring sunny starts with small s. School is also not present here, so this should be passed. Then this should be omitted because school is present in here, as exactly as given in a substring list. School is also present here, so we will omit it. Sunny is present here, so it should be, it should not be passed through. So we can see that. So what else we can do is we can also do is like we can uh, capitalize. So we will capitalize it. Okay, so I think it's Z E. Yeah. So now as we have capitalized it, we have capitalized I. So what has happened is now, yeah. So now Sunny has passed. Sorry, this is not passed. This thing has passed, because when you have capitalized this has become capital S, but here you have a small s. So that is why they both have passed, and this Sunny also has passed because this has been capitalized. What you could do, you can play with you can use upper, you can use lower, you can use many combinations, you can change the combinations here, and you can play with all those things for your better learning. So this is how we are going to deal with this problem of removing associated data for the given substring value. So this will be all for